Now you can also do a lot of these calculations on your calculator. So I'm going to just take out my Ti-83 calculator here and show you some tips. So these tips are going to be found under the math key. And one thing we can do is we can do those factorials. So let's say I wanted to do 10 factorial. I could, or let's do something smaller. How about 5 factorial? So I can hit that 5, then I hit the math key. And you want to go over to PRB, which really stands for probability. And you'll see a number 4 here, that exclamation point. So if I hit that factorial and then hit enter, it will do that calculation for me. So it'll save a little bit of work. It can also do this permutation calculation. So if I go back here again, I'm going to hit enough, and then go over here to probability, and you'll see it here. See, there's that NPR. I'm going to hit that, and then the boxes will open so I can type in my values. So I'm going to choose 10 for the first one, and then hit the over arrow, 4 for the second one. Just like I did here, I'm going to hit enter, and you can see you get that same value of that 5,040 that we did here. So you can also use your calculators if you want to. All right, let's do some more examples. Now, you may also want to order a group of n objects in which some objects are the same. So for instance, let's consider the group of letters A, B, B, C. So this group has 4 A's, 2 B's, and 1 C's. How many ways can you order such a group? So you may think that we want to use this formula here, right? Well, I have 7 objects, I'm going to choose 7. So you may conclude that there are 7 factorial different possible ways to do this. But actually, it's not really quite this case, because even though you have 7 things, they're not all distinct. So when you're ordering them, you know, this A and this A are really not different things. So we shouldn't count those different orders twice, right? If I put the first A first and then I put the first A second, they're both still A's. It doesn't matter. So although we're caring about order here, it's hard because we have some repeated values. So it's not really going to affect how the combination looks. So we actually want to be careful about distinguishable permutations so that these repeat letters are not really affecting the outcome. So the formula we can use for that is actually this one right here. So our n here, in this case, we have 7. So there's 1, 2, 3, 4, 5, 6, 7. So there's still 7 different options. But what we do is we divide out by how many of each type there are. So notice that there are 4 A's, there are 2 B's, and there's 1 C. So in the formula, it's going to be a little bit different. You're going to divide by 4 factorial, 2 factorial, and 1 factorial to actually get the true number of distinct permutations instead. So your 7 factorial is 7 times 6 times 5, 4, 3, 2, 1. Now 4 factorial is 4 times 3 is 2 times 1. 2 factorial is 2 times 1, and 1 factorial is just 1. So we do have some things that cancel out, right? The 4 cancels, 3 cancels, the 2, the 1. I have other stuff left over though, so I do need to multiply what's left. So if I go ahead and do that, I have 7 times 6 times 5 in the numerator. And then really in the denominator, I don't really need these 2 1s because they're not going to change the value. So 2 times 1 is still 2. And when I multiply this out, I get 100. So there are 105 distinguishable permutations, not 5,040. And again, the issue is that we have these repeat values that really are not distinct, right? This A compared to this A are not truly different. They're the same thing. So it's going to affect how many distinct permutations we get. So here's another formula that we can. All right, let's look at this one here, example 4. Oh, there we go. So a building contractor is planning to develop a subdivision, and the subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. How many distinguishable ways can the houses be rearranged? Well, altogether, I have 6 plus 4 plus 2 equals 12 different items, right? So I have 12 items, but they're not really all distinct, right? So I have 6 one-story houses, I have 4 two-story houses, and I have 2 split levels. So even though I have 12 items, I have a lot of repeats of the same style. So for our distinguishable permutations, we're looking at instead 12 factorial being my total on the top, and then I'm going to divide by 6 factorial, the 4 factorial, and the 2 factorial. So the different, how many repeats I have of each group. So I have 12 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. For me, I just like to write these out. I just find it it's pretty easy to go ahead and do for these smaller numbers. And then I can go ahead and cancel things in common. So the 6, 5, 4, 3, 2, 1 is going to cancel this piece right away. Now, you can keep canceling here. If you want to simplify at this point, you can. So for instance, you may notice that a 4 times 2 is the same thing as an 8, right? So we could kind of clear things out a little bit more here. I don't need this one. I don't really need that one either. So what I'm left with is 12 times 11 times 10 times 9 is 7. And then in the denominator, I only have a 3 and a 2 left, which I still could cancel out too, but those ones, I kind of canceled the easy things first. And if you multiply this all out, you're going to get 13,860 distinguishable